What if I told you that the secret to understanding fraction is actually pizza? Stay with me, I will show you why. A fraction is just a way to show a part of a whole. It tells us how many pieces we have, out of how many equal pieces the whole was split into. We write it with two numbers. The top one is the denominator. It counts how many pieces you have. The bottom is the denominator. It names how many pieces make the full pizza. Now look at this. If you eat half a pizza, it's the same amount as eating 4 small squares of an 8-piece chocolate bar. Even though the numbers are different, the amount is the same. In math, we call these equivalent fractions. Stop adding the top and bottom numbers. If you do that 4, you get which simplifies right back to. But half a pizza plus another half should be a whole pizza, not just another half. Let me show you how to fix this for good. Most people try to solve it like this. It looks right, but look at the logic. If you join two halves, you have one whole. You don't just have two smaller slices from a 4-slice pizza. The easy way is actually the wrong way. Here's the rule. The denominator is the slice size. You can add apples and oranges unless you call them both fruit. In math, you can add slices unless they are the same size. If the denominators don't match, we have to resize them first. The least common multiple, LCM, of 2 and 3 is 6. We want everything in 60s. Multiply 1 over 2 by 3 over 3 and 2 over 3 by 2 over 2. Multiplying by x over x is just in multiplying by 1. The value stays the same, it just looks different. Now we have 3 over 6 plus 4 over 6. Add the tops, keep the bottom. Multiplying fraction is the most straightforward rule in math. It's top times top and bottom times bottom. Numerator times numerator, denominator times denominator. But wait, why multiplying 2 over 3 and 3 over 4 just to simplify later? If you see a 3 on top and a 3 on the bottom, divide them right now. This keeps the number small and saves you from doing extra work. Always cancel before you multiply. Dividing fraction is just multiplication in disguise. So why do we flip the fraction when dividing? Think about it this way. You have 2 pizzas and you want to cut them into 1 over 4 slices. The question is, how many quarters are there in 2 wholes? 2 divided by 1 over 4. 2 times 4 equals 8. The logic is simple. If each pizza has 4 slices, then 2 pizzas will have 8 slices total. Flipping the second fraction with the reciprocal is just a mathematical shortcut to turn the division into a multiplication that makes sense in the real world. What if letters show up? Don't panic. The rules stay the same. Treat them like numbers, but with one major warning. Only cancel factors, never terms. You cannot cancel the x in x plus 1 over x minus 1. If there is a plus or minus sign gluing the numbers together, you can't touch them. Respect the addition. Example question: who actually has the best performance? We're going to find out which athlete has the best success rate at blocking shots. Instead of dealing with messy divisions, we are going to compare the ratios using a much simpler method. First, let's roll out the obvious choices. Athlete 1, 20 successful blocks out of 20 attempts. Athlete 2, fewer blocks than Athlete 1, but with more attempts. Athlete 3, same situation, more attempts but fewer blocks. Clear, Athlete 1 is outperforming Athletes 2 and 3. Easy start. Round 2, Athlete 1 versus Athlete 4. To compare them fairly, we need to put them on same scale. Let's find a common ground of 120 attempts. Athlete 1, 20 out of 13 is the same as 80 out of 120. Athlete 4, 3 out of 4 is the same as 90 out of 120. So even though Athlete 4 has a smaller sample size, they are actually more efficient than Athlete 1. Athlete 4 takes the lead. The final showdown. Athlete 4 versus Athlete 5. Let's imagine both athletes faces the exact same number of shots, 4 attempts each. Athlete 4, at a rate of 3 out of 4, they would score 30 blocks in 40 tries. Athlete 5, 8 out of 10. At this rate, they would score 32 blocks in 40 tries. And that means the winner is Athlete 5. With the highest success rate, Athlete 5 is officially the most efficient player on the court. If you need a game changer, this is who you sub in. Whenever you need to compare fractions or performance rates, just multiply the numerator and the denominator by the same number. This levels the playing field, allowing you to compare values instantly. No calculator required.